Let us now study about a simple microscope, which is also used as a magnifying glass. Or a magnifying glass is the one which we call a simple microscope. About this we can write. It is a converging lens of a small focal length. And here we can write, in order to use a simple microscope, it is held near the object such that the object is placed between its focal point and the optic center, and eye is placed on the other side. The observer's eye is placed on the other side. I think all of you might have seen magnifying glass in your physics labs, or you might have used it at home also. And using a magnifying glass or a simple microscope, here we can see that image produced, as I've already stated, that object is kept at such a position that it is between optic center and focal point of the lens. So here we can write the image produced will be erect, virtual, and magnified. Here we can discuss about various cases of magnification produced by a simple microscope. And here we can see for eye, image can be seen if it is the position between near point and infinity. So we are going to discuss about two limiting cases. Say we are given with an object of height h, and it is placed at near point where with some strain human eye or observer's eye can clearly see the object. Then in this situation, the angle subtended by the object at the human eye is taken as the angular size of object. So here angular size of object is, if object is of height h, this theta we can write as h by d, because here h is very small. And in this situation, if this object is seen by the same observer by using a magnifying glass, here you can see if this is the same object of height h, and at some distance we place a converging lens or a simple microscope or magnifying glass, and on the other side we look at it, then here you can see one light ray which is passing through the optic center will be going as it is, and the other one which is going parallel to the principal axis, here you can see it will pass through the focal point of object, and from this side, if the observer eye is looking onto the object through the magnifying glass, the image seen would be somewhere here, and this is the image which is seen by the observer when he sees through the magnifying glass. And say if this angle is theta prime, then we can write this h prime or angular size of image is, this angular size we can write theta prime, which is equals to h prime by this distance, and this distance should be equal to the least distance of distinct vision, so that I will be able to clearly see the image, as I is considered to be very close to the magnifying glass or this converging lens. So in this situation, to clearly see the image, this theta prime, the angular size of image, must be equals to this h prime by d. Now in this situation here we can see, if we find out the magnification produced by the lens, then here we can see magnification of a simple microscope is, a magnification we write the size of image by size of object, and here these sizes we can write as the ratio of magnifications, and in this situation Here you can see this will be theta prime by theta. So in general, for simple microscope, the magnification is not generally directly defined in terms of size of object and images. It is taken as a ratio of angular size of image to angular size of object. Now in this situation, if we also find out the value of theta prime in terms of h, then you can see if this distance is u for which the image is obtained at d, then this theta prime we can also write as h by u. Now if you substitute the value of theta prime as h by u and h prime as theta prime as h by d, then here we can write it h by u divided by h by d, which gives you the magnification as equals to d by u. And the value of u you can easily obtain in terms of focal length such that image is produced at a distance d behind the object. So here the value of u by length formula you can state in terms of magnitude as u is equals to df by d plus f. I'm leaving it as an exercise to get the value of u in terms of magnitudes of d and f. Then on substituting the values over here, you can see this d divided by df by d plus f. Here this d gets cancelled out and the magnification we are getting is d plus f by f, or it can be written as 1 plus d by f if f is the focal length of the lens. So this is the magnification produced by the simple microscope if the final image is obtained at near point of the observer. So this we can also write this is the magnification when image is produced at near point of observer. Another case also here we can see when image is produced at infinity when eye is not having any strain. So that will be the situation we can relate here, that if in the situation for the same lens having focal length f, if the object of same size h is placed exactly at a distance of focal length of the lens, then we know that its image will be produced at infinity because the rays which are incident on the lens from the object will become parallel after refraction. And from this side, if observer will look into the simple microscope, the image will be seen at infinity. And say in this situation, the angular size of image is theta prime, then here theta prime we can write as h by f. So here if we find out the magnification, this is the magnification when image is produced at the near point, so this can be written as md. And if we find out the magnification when image is obtained at infinity, it is written as m infinity. And here again it is theta prime by theta. So here the value of theta prime we can write as h by f. And the value of theta we have already seen the angular size of object. This is h by d. And the magnification we are getting here is d by f. So you must be very careful about the two magnification. It is 1 plus d by f when image is produced at near point, and magnification is d by f when image is produced at infinity. So for the two cases we are finding out the magnification for a given specific object distance from lens. We can easily find out the magnification for that particular case also. So this is the magnification for image at infinity, and this is the magnification of simple microscope for magnification for image produced at near point of the eye.